Hi everybody!
So this is my Radar project, which utilizes firstly Arduino, which is an open source electronic prototyping platform that can enable user to create interactive electronic objects. And it also uses processing, which is an open source graphical library and integrated development environment. So in this project, I'm going to use a radar, which as you know is a long-range detection system, and it uses radio waves to establish certain parameters of an object. It's, for example, like the range, speed, and position. It can be used in aircrafts, missiles, marine, weather predictions, and automobiles. But in this case, I'm going to determine the presence of any object in a particular range. So I've used firstly an ultrasonic sensor, which is this one, and it detects the objects. I've also used a small hobbyist servo motor, which rotates this ultrasonic sensor. And then to support these components, I've used a G clamp. And then finally, I also used a Arduino Uno board, which controls these components. So it will display the range of an object visually like this. And
As for the program, to turn on the ultrasonic sensor and to tell if the object is in or out of range, I used Arduino. So first, we're going to include the servo library. And then we move down here. We're going to define the trig and echo pin of the ultrasonic sensor, and that is 10 and 11 respectively. Next, we're going to create variables for the duration and the distance. We made duration long and distance integer. In the next line, we create a servo object for controlling the servo motor. Now we move on to the void setup, which will basically only run once in the program, and after that, it will not run anymore. Basically something usually we use for setting and defining. So for the trig pin, since it's pin mode, we will actually set a pin to input or output. So in this case, we're going to set the trig pin as an output. The trig pin has already been defined up here, remember, as 10. And then for echo pin, we set the echo pin as an input. Echo pin is connected to 11 in this case. And as for this is just for the serial monitor. It's really important when you put that, but we'll set it at 9600 in this case, which is usually the default one. Next, my servo.attach 12 will basically define on which pin the servo motor is attached. In this case, it will be 12. In the way I connected it. Now we move on to the void loop, and in the void loop we will run it. We will loop again and again. So we will run more than once, as long as the program will keep continuing. First, we're going to look at this for loop. The condition is that I is equal to 15, and it will keep incrementing until I is equal to, less than or equal to 165. This is basically the number of degrees that we've set for the servo motor to turn until. So it will rotate the servo motor from 15 to 165 degrees. Why I did this is because it can only go 160 degrees at max, and some servo motors actually cannot go 180 degrees, but even less. So it would be like a safety precaution that we make it less than 180 degrees so as not to damage the motor. Now, we're going to move on to my servo.write of I. This will basically scan the position of the servo. And we do this for 30 milliseconds. Next, we're going to call a function for calculating the distance measured by the ultrasonic sensor for each degree. So this, we're going to call a function called calculate distance, which the ultrasonic sensor will have a task for to do, and it's down here. Int calculate distance. This is the function that we call. This is a function for calculating the distance measured by the ultrasonic sensor. At first, we set the trig pin, and we set the trig pin at low for 2 microseconds. And then after that, we're going to set it on a high state. Set the trig pin on high state for 10 microseconds. This will generate ultra sound for just 10 microseconds during this short time while the trig pin is still high. Then we set it as low again. And now we're going to calculate duration. It reads the echo pin and returns the sound wave travel time in microseconds. So to find the duration, we actually do pulse in echo pin of high. This means that it will read the echo pin, and then after that return the sound wave travel time in microseconds. Now in the next line we have distance is equal to duration times 0.034 divided by 2. So basically the math here behind it is we're trying to get the distance, but in order to get the distance, we need to multiply the received travel time value from echo pin by 0.034 centimeters per microseconds, which is, as we know, the speed of sound is 340, moves at 340 meters per second. And so if we convert this to centimeters per microseconds, we get 0.034. And distance is equal to the received travel time value times the distance. Now we divide by 2. And why do we divide by 2? It's because the sound wave that goes to the object in front of it will have to go back to the sensor. So when the ultrasonic sensor releases the echo, it will have to go back to the ultrasonic sensor. So it just doesn't go once, but it's reflected back. So the ultrasonic sensor is, when the time travels back, it actually calculates double the time it takes to go there, because it has to also go back. And then we just return the distance, because since this is a function, we're going to return back the distance measured. And then here, all we're doing is just basically we're just printing out these values that we've got into the serial monitor, just sending the values and the characters into it. Then we're going to, in this for loop, we're just going to repeat everything that happened before. Instead, for 165 to 15 degrees. So we just repeat the previous lines, but instead for 165 to 15 degrees. That means we go backwards to the original point that we started. The servo motor will travel back. And that's it for the program. As for the code for processing, I did not create any of this code. It was created by Dejan Nedelkovski, and I found it on his website, howtomechatronics.com, in this website. And he had written the code, he had explained about the Arduino Radar Project and also created the code, which I used from here.
It displays these red lines, which is actually the distance. If you notice carefully, for example, if I put my hand close to it, it will read that it's about less than 10 centimeters. So it actually has positions: 10 centimeter, 20 centimeter, 30 centimeter, 40 centimeters, the range for how far away the object is. It also shows the angle at which the servo motor is turning at, and in addition, the object, if it's out of range or in of range. In of range will be less than 10 centimeters, as you can see, and it will display the angle as well as the distance.
Thank you very much, and I hope you enjoyed the video.